to the fourth part of my introduction to Kansei Engineering. My name is Simon Schlitte. I'm a researcher at Linköping University. In the first part, I've been talking about what is effective design, why is effective design needed. I hope I convinced you that you would need the methodology in order to grasp this Kansei, the effective parts of the product, and transfer them into some type of product design. That has been done in the last part, latest part. And now we put it to practice. I will show you in this part how you do that practically. First, a little bit of dry swimming. So let's see, I will show you the structure, how it's done. And then I will go through this very structure with a concrete example of a drinking bottle for fizzy drinks, which we have actually been doing as a project before. So stay tuned. In the following part, I will go through a model of Kansei Engineering. I will go through the so-called Figure 5. I explain you soon what that is and why it's called that way. And also I will show you how to perform a Kansei Engineering study, which steps to do, when to do it, what to expect, what you put in, what you put out, and so on. So more or less a cooking book on Kansei Engineering. This is what we internally call the Figure 5, and I think that has been spreading towards the research community as well, this expression. The reason why it's called Figure 5 is when it was published for the first time, it was Figure 5 and that particular paper. And since then, it has been used as Figure 5, or it's been called Figure 5 a couple of times. Anyhow, what you see is that the Figure 5 has a diamond shape. We start up with the product domain up here. In the product domain, you look for the user, understand the user in depth. It's not only just screening users between 20 and 25 years old male student, or uses a 55-year-old mother of two. No, you should understand what the user has for purposes with the product. What is the lifestyle of the user? What other products does the user use? What other needs does the user have? Are there any products which are similar, fulfilling the same properties and needs of the user? When you have understood this person, this fictive person, representing this particular group in depth, you can describe the new product this domain from two different angles. From the semantic space, that is what we already did in terms of the Kansei, describing adjectives and so on. We go through it in a sec. And then from the space of application, where you have physical properties which you define. That is then brought together in the synthesis, and afterwards we build a model. So going on with the semantic space, that is, as I told you, more or less the same thing as we did in the first chapter when we were looking on the Kansei. Or that was the second chapter actually, when we were looking at the Kansei. It is based on Osgood's semantic differential methods, way back from the 1950s. The purpose here was to identify what does a semantic description link to physical properties. And we can define the semantic space, and that's really a mathematically a vector space which we define by using PCA effect analysis, for example, but a more simple way we can use chord systems or affinity diagrams. I will show you later on in the next chapter how that has been done. But in a sense, the semantic space captures the feeling dimension, the emotional, the affective dimension of the user, and brings it to the table. The space of application, on the other hand, does the similar thing, but from a physical perspective. So it collects features, physical features of the product. Physical features does not necessarily mean it must be tangible. It can be a service as well, but features, physical features which actually occur. If it's a postal service, it might be the color of the delivery car or the size of the package box or so. If it's a watch, it could be the material of the housing. It could be the color of the dial and so on. Any product has, I guess, thousands, 10,000, maybe 100,000 of different properties, features, but not all of them are considered by the customer as important for the affective impression. So we need to prioritize. We need to find we need to find ways to define the properties which are important for the affective impact the users have. Okay, now we know the user himself or herself. We know the products she is using. We have been defining which product we want to develop. We have described this type of products from the semantic point of view. We also know which are the properties which we could modify in order to get the right impression. And now we have to bring that together. And that is something which makes Kansei Engineering unique. So in this synthesis phase, we link these two spaces together. That can be done manually, where you actually have clustered your words, know what the general Kansei is or the general Kanseis are. You also know which are the physical properties which you can modify, which you can manipulate, and then bring that together by sitting together, having a discussion. That's the easiest way. But when we use Kansei software, Kansei Engineering software, we usually do that in a little bit more sophisticated way. Mostly we use linear regression models. There are different models available. You can see them here on the right hand side, QT1, OLI, MOLI. I don't want to bore you with the differences here. You could use other things like fuzzy logic, graph sets analysis, and so on and so on. There are many possibilities, but anyhow, I will show you some of the methodologies in the next chapter how they are used. And when we have done this linking, we do some type of model building. This model building can be a formula, meaning that if you add this and this and these products to these features to this extent, you will have a sporty feeling of the car. Or if you remove this, you will get less scariness. Or if you add here, you can have more delightness, and so on. So those things can be done. These models have been previously patented by companies. So there is a manufacturer, I can say it's Toyota Material Handling, and they have been working with Kansei Engineering and have been able to define the best combination between spring and damper for their trucks, and giving the right driver's feeling or best driver's feeling, and that can be patented and give you the edge over other competitors. Okay, so far it was quite abstract. So let's put figure 5 to work. Let's have a look on a real example. I chose something very simple, also something which you can relate to, because I think everybody of you have been testing carbonized drinks, or at least know what carbonized drinks are. And we will develop a bottle design for carbonized drinks. Okay, let's start with the domain. We are looking for who is the customer group we are intending and what are their interests here. So this customer group here is for healthy lifestyle. They are sports related. They drink carbonized drinks on the go, meaning they are on the bus, on the train, or somewhere. And they would like to have a healthy drink as an alternative to fizzy, sugary stuff, drinks, and so on. So there should be a healthy component in there. Also, this domain, this group, tend to be active and younger persons. Um, so that's why they're sport related. So what we have to consider as well is that what are these products for? So when we finding people for the interview later on, or for the questionnaire that software will generate for us, we need to find out how can we find these persons, what type of energy drinks, what type of healthy drinks do they use. So as an inspiration for the domain we're looking here, these are images which are representing this type of people, this type of lifestyle. If you have a look on the drinks which are on the market, they look very much like that. It's not. I just picked these images randomly, but you can easily understand that these are very colorful packaging. These are very colorful drinks in some way, and those images are representing the healthy aspect in there. So while you're here, might have a focus on sport and energy and so on. We also want to integrate some type of healthiness. Still, if you go back here, you can see here we have this fizzy drinks. Here we have energy aspect. Here we have healthy aspect. Those three things should do make up the domain. Okay, now let's describe this domain from different angles. So we start with the semantic space. We use a affinity diagram. Affinity diagram works basically like that. I assemble a group. I present the definition of the product domain to the group, and I provide them with, for example, post-its. We have a brainstorm session. Everybody comes up with words describing those products. In this case, the bottles for the fizzy drink, or the bottle for the healthy fizzy drink. We then bring all these papers together. We will maybe add some words from other sources like commercials or persons who are experts on that particular domain, and then aggregate them. You remember the pyramid from slide 4, I guess. And then we find out which are the words which should be representing, and these words we call the Kansei words, KVs. Then looks like this. Here we have all the post-its collected for a product. We then find out some of them are grouping together into certain groups, and these groups then grouped together on a higher hierarchy in some way. Okay, now we go to the space of properties. Describe the same domain, but from a physical property perspective. For this, we use Pareto chart. Different possibilities of tools, of course, possible, but the Pareto chart works quite well. So we are asking people about what are the properties of a bottle which stimulates your affective impression of it, and we just let them brainstorm. Then we just record the number. How many times do we have that? We order that, so the content of the color of the content was mentioned about, what could it be, 52 times maybe. The translucency of the content was mentioned 48 times. The illustration was mentioned 35 times, and so on and so on. And then we apply something which is called the 80-20 rule, meaning that 80% here of the cumulative of the total mentions will be able to be explained by just 20% of the properties. Does not mean that those things are less important people use, but those things are less considered when you're looking at bottles for fizzy drinks. So the color, the translucency, the illustration, and the label is something which is the most important. Then the form of the lock could be included or not. In this case, we chose not to include them because it was too different from those things. Illustration and label belong together in some way. Translucency and color both refer to the content. So we thought that would be enough to describe the bottle itself. What we did then was finding representative bottles, and here we choose two of the dimensions. We had this content here, translucency of the and color, and here we had illustration and label. And then you can see that for we had translucency, we had transparent, weak, and non-translucency. We had a concrete illustration, meaning that we had real fruits here, or we had some type of abstract things where we had umbrellas, stuff, and you can see the difference here. Then we were going out and looking for what do we have, which properties or which products which can represent this so-called dummy coding table. We were lucky here finding real samples. That is the best way to do. But on the other hand, if you can't do that, sketches or computer renderings will do the trick as well. In the synthesis, we did the following. We used Kansei software, and I'm sorry for this picture, that is wrong. It should be one of the bottles here. So each bottle was presented, and then customers were asked to rate that on these so-called visual analog scales. So click here. Soft, how soft is it? This one. How sweet, how artificial, how and so on. Is do you perceive the product? And the software then can automatically interlink the results. So one of the findings is here, for example, say Fanta probably is a product which you know. It is rated of good, natural very low, healthy very low, natural so they're nutritious, youthful very high, active somewhere on some medium level, honest not that good, simple. So in general, Fanta does not have a real convincing profile. Ramlösa, which was a natural water, came out to, or it was a flavored water. There was no sugar in that. It was just a flavor of lime or so. Came up quite good, very similar to Bon Aqua, as you can see here. And then we had products like this one, Loca Crush and Trocadero. No, Loca Crush, for example. This is a sugar reduced fizzy drink. It's not, it is not per se healthy, but it's perceived to be more healthy than Trocadero and Fanta, for example, which marked the lowest one, because everybody knows it's good, it's tasty, but it's not very healthy. You would probably get a very different point of view if you would ask other people not belonging to this domain. But remember, the people who rated these were active, sporty people. And those people were probably not preferring Trocadero and Fanta, but something like water. And then out here, we had one product which is raw. It's a Swedish product which is a natural juice, a juice for made from, yeah, it's a good product made from natural resources, and no sugar added, and all that stuff. So that is a the standard product Swedish sporty people usually consume. Yeah, more or less. That's why it came out so high. But you can distinguish the three groups. This extremely expensive and healthy product. Then you have the water product. You have the cheap, the standard fizzy drinks inside here, and then you have a compromise between. This is the Loca Crush, which is the sugar reduced fizzy drink in some way. There's one immediate result, and I think that gives you a lot already. So if I would be Coca-Cola company, and I'm sure they know that their products are not perceived as very healthy, but they would say, okay, how can we do something more healthy? Yeah, well, we could go for something here. Bon Aqua is, by the way, Coca-Cola company as well, so they can do it. They know how to handle things like that. What other finding do we have here in the model building? So when we apply, in this case, linear regression analysis, and I'm sparing you how we did that. In the case of software, you just press a button or flip a button, and it will give you these results already. But it's important for you to understand what the outcome here, and the way how to achieve these results is subject to another lecture. So after applying the quantification theory type 1, you will get two things. No, three things actually, but two things here. For example, healthy and fresh. So imagine if I have to go back here. Imagine I would like to do something more healthy and fresh. So I'm producing something here. I want to increase that. How can we do this? And then we could go to this type of model building. We get the result and we say healthy and fresh. These are made up by a transparent color and a concrete illustration. You see, plus positive towards fresh, minus negative towards fresh. But what happens if we want to have naturally as well? Then we can see, okay, transparent and the concrete illustration is working as well. Absolute no abstract illustration. So the illustration is very important here. We can also see that natural, that strong color could attribute to natural, but not necessarily for fresh and healthy. So if we want to have natural as well, we would choose transparent and concrete illustration. if we move here, we will still have some parts, maintain some parts of healthy. We will and fresh, because this, if we go to strong color, this does nothing negative to healthy, but it does not do any positive to healthy and fresh either. But if we go here, we could also include things like active, useful, exotic, which does not have anything on transparent. So it's compromise. If we are on healthy, fresh, natural, and we go for this, then we also can include those things. Not simple, however, but those things. But what would have if we want to go for useful? Yeah, well, as you see, if you can add that as well by going here. You add useful, and you don't have these, and you don't have any negative effect on fresh and healthy. What more findings do we get there? We can go in more in detail. We can have a factor analysis, having a look on which of the words do belong together, and what dimensions, what emotional dimensions do people have, or preferences do they have when they look at this type of fizzy drinks bottles. So using a so-called factor analysis is it's a standard statistical tool. There's software for that. I don't go into it how it's done. Once again, we have separate lectures on this particular way to evaluate data. But what the PCA does, it plots the different words into a space. And this is really a mathematical vector space. And what we can see here, that we have that they build groups. They cluster together, active and useful clusters together, exotic, exclusive clusters together, honest, natural, fresh, simple clusters together, healthy and nutritious clusters together. And then we have one word which is here, good, close to the origin. But you can see that good, close to the origin, is some type of antonym to healthy and nutritious. That's an important finding. So people apparently think that something which is healthy and nutritious not necessarily is good, or something which is good is not necessarily healthy. It could even be very different. Could also be a reason that this particular product we have been choosing is not very tasty. That there could be a kind of, but in general, I would say that that's right. So what we see here, what conclusion we can draw from this is that we have different dimensions, 1, 2, 3, 4. This is what people group their products into, and then we can decide, okay, how should our product be placed? We could do a benchmark. Where is Fanta? Where is Ramlösa? Where is Bon Aqua? And where should our new product be placed in relationship towards those dimensions?
This was the fourth part, the longest of the parts, but I thought it would be nice to have that everything put together, wrapped together. It gives some type of better comprehension, I would say. What are the takeaways from here? Well, there is a structure on Kansei Engineering. There is a way with which you can standardize, go through and grasp feelings, translate them into products. What is unique to other product development methodologies is that there is a distinction between the feeling, a semantic space on one hand side, and there is the physical properties, the space of properties, which is then linked together. Also, there are no interpretation steps in between. There are no engineers or product developers involved in that. Just the data which is collected from the customers is fed into the system, and the system will use it as it comes in. So as objective or as unbiased as possible. Then, of course, we've been talking about how that's working in practice, and we will go deeper into other examples in the next and final part.